Hello, students. So today we are going to solve the topical past paper question from electrochemistry. And the question is that an electrochemical cell consists of a half cell containing V plus 3 and V plus 2 ions, and another half cell containing VO2 plus and VO plus 2 ions. So we have to calculate E naught of the cell. So for example, these are our two half cells. Obviously, both are containing ions. So therefore, this will be the setup that we have to draw it also in the next question. So let's say we are having V plus 3 and V plus 2 ions and we are VO2 plus and VO plus 2 ions. So we have to use the data booklet. So let's open the data booklet and you can see these uh, two equations over here. So its reduction potential when V plus 3 gain the electron it from V plus 2, so it's minus 0.26. And you can see VO2 plus when it gains the electron it from VO plus 2, so its redox potential is 1.0. Now you can see that obviously how can we find out that which one will be the cathode and which one will be the anode obviously. So the more the negative value, the more it has tendency to lose the electrons, obviously. So the more the tendency to lose the electron, it will act as a node. Okay. So what's our formula to calculate the E naught of the cell, obviously? So it's like E naught of the cell is equal to E naught of cathode minus E naught of anode. Okay. So we have to identify which will be our cathode and which will be the anode. Okay. So obviously this will be cathode because it has a greater redox potential, and this will be anode. Okay. So I will put in these values in the question obviously. So just write as E naught of the cell is equal to E naught of cathode minus E naught of anode. Okay. So E naught of the cathode is actually 1.0. I will just put it over here. So it's actually 1.0 minus. And E naught of anode is minus 0.26. So it's minus 0.26. So its answer is 1.26 volt. Okay. So I have to write the ionic equation for this reaction. So it's very simple. You will just add up the reactants for the two equations and then you will add up the product for the two equations. So the two equations are V plus 3, it's gaining electron to form V plus 2. So for example, if how will I write it? So let's say it's like V plus 3 plus 1 electron. So it's forming V plus 2. Okay. And obviously you can see that in this equation, because it has more tendency to lose electrons. So obviously the equilibrium will be shifted more toward this side. So I can make a net equation from it, obviously. So net equation will be V plus 2 will lose electron and it will form V plus 3. Okay. This is the, you know, oxidation equation. Then we talk about the second equation. This is obviously, this is plus 1 and it is acting as a cathode. So therefore, this equilibrium will be shifted more toward the product side. So I can also make the net equation from it. So it will be VO2 plus 2H positive plus electron and it will be VO plus 2 plus H2O. Now, how will I write the net equation? So this will just, electrons will be cancelled out of each other and then we can just make V plus 2 plus VO2 plus 2H positive and it forms V plus 3 plus VO positive 2 plus H2O. So this is our net equation. Okay, so the same equation, you write it in the answer. Okay, so in this way you will find out the net equation. Okay, so this is the ionic equation. Now you have to draw a fully labeled diagram of the apparatus you could use to measure the potential of the cell. Include the necessary chemicals. So this is the diagram, and because it is the ion combination, so you know that for this purpose we use a platinum electrode, and this is a porous platinum, and it's a platinum wire, Exactly as you have used it for hydrogen SHE, stranded hydrogen electrode. So the same setup is like that because for ions we use this. Okay, so and you just write these ions as we have already seen it in the our data booklet. Okay, so you can draw it now. The next question. Use the data from data booklet to predict whether a reaction might take place when the following pairs of aqueous solutions are mixed. If a reaction occurs, write an equation for it and calculate the E naught of the cell. Okay. So for this purpose, again, we are needing a data booklet. So that's why you can just see over here that, for example, it's like um, obviously SN4 positive. So as you can see, it's SN4 positive, obviously. So we use the equation of SN4 positive. So it's taking two electrons and it's forming SN positive. Its redox potential is plus 0.15. Now the second one is V plus 2. Okay, V plus 2, obviously. So you can see over here that SN4 positive is like obviously it has to convert into SN positive too because it will obviously gain the electron. Okay, and if we just talk about V plus 2, so it's minus 0.26. Okay, and obviously this is more negative. So if the value is more negative, it means that again that will act as anode and it will act as cathode. Okay, so if it is acting as cathode, then what can we do? Obviously, if it is acting as cathode, the reaction is equilibrium is shifted more toward the forward direction. And here, the equilibrium will be shifted more toward the left direction. It will lose the electron. So we can find out that obviously this will gain the electron, this will lose the electron. Now I have to obviously write the E naught of the cell. So how can I write the E naught of the cell? Again, the same formula that will be used. Yes, the reaction will occur, okay? And what will be the equation, obviously? So you can see, how can you make the equation? If I just say that this SN4 positive will take the electrons, so it will form SN4 positive will take two electrons and it will form SN positive 2. The second is like V positive 2 will lose electrons because it is acting as a node. So V positive 2 will lose electron and form V plus 3 plus 1 electron. Now, we have to balance the electrons, obviously. So what will we do? We will multiply this equation by 2, okay? So I will now write the net equation, obviously. So it will Sn positive 4 plus, now it will be multiplied by 2. So 2V positive 2, okay? And obviously electrons will be cancelled with the electrons. So therefore I will not write that. And this is Sn positive 2 plus 2 V positive 3. Okay. So this is the net equation, ionic equation for this reaction. And E naught of the cell is actually, how can you find out? Obviously, it's like what is E naught of the cell is equal to E naught of cathode minus E naught of anode. And we have decided which one is cathode and which was an anode, obviously. So this one is cathode, it's positive 0.15 and positive 0.15 minus 0. I think so it was 26. Yes, minus 0.26, obviously. So its answer is positive 0.41. And obviously, if it is positive, so it means that this is a physical reaction. Okay. Now the next one is VO plus 2 and Fe plus 3. Okay, aqueous. So does the reaction occur? And if it will occur, then I have to write the equation. If it doesn't occur, then there is no reaction. I will not write the equation, obviously. So this is VO plus 2 and Fe plus 3. Okay. Now let's see. VO plus 2 And here is Fe plus 3. Okay, now Fe plus 3 has to gain the electron. Okay, and if we talk about Vo plus 2, and obviously I have to convert this Vo plus 2 and I have to react it with Fe plus 3. Okay, so in both cases, like if you can see over here, Vo plus 2, Vo plus 2, both of the equations are more positive than that of Fe plus 2. If these are more positive, then they cannot act as an anode. They cannot act as an anode. Why? Because obviously their redox potential is greater than that of iron. And iron cannot, Fe plus 3 cannot further lose the electron, as you can see over here. Fe plus 3 cannot further lose the electrons to form Fe plus 4. Okay, it can only form Fe plus 2 or Fe plus 3 ion. And Vo plus 2, its redox potential is greater than that of Fe plus 3. So it cannot act as a node. It cannot lose the electron whenever it is reacting with Fe plus 3. It means reaction will not occur. So reaction will not occur. No. Reaction will occur, and obviously equation will be, you can write is like Vo plus 2 plus Fe plus 3 aqueous. Okay. So it will have no reaction. And again, here you can also write as no, not feasible. Okay. So that's the thing about this question.